Hi friends, so Bibinka solved this problem using iteration method. So there are four methods to solve recurrence problems of time complexity. One is iteration and the substitution proof and some more like master theorem and all there. So Sir explained the two problems with iteration and substitution proof method. So for this problem t of n equal t of n minus 1 plus n. So for iteration method, uh, first step is we are expanding this t of n minus 1 based on this formula. So here n will be n minus 1. So n minus 1 plus n for this formula is t of n equal to t of n minus 1 plus n. So for this t of n minus 1, t of n minus 1 plus n is n minus 1. So to expand this t of n minus 1, we again applied the same formula. Uh, so we expand, right? Plus 1. So uh, uh, this is t of n minus 2 plus n minus 1 plus n. Again, for this t of n minus 2, we need to apply the same rule as t of n equal to t of n minus 1 plus n. So for this t of n minus 2, again if we apply the same thing, t of n minus 2 minus 1 plus n is n minus 2, right? And then we already have t of n minus 1 plus n. So now it is t of n minus 3 plus n minus 2 plus n minus 1. So two times we expanded the same thing, t of n equal to t of n minus 1. So for t of n minus 1, again we have applied this formula, and then for t of n minus 2, we again applied the same. So three iteration we have done. So if we do the same until k steps, our t of n will become like t of n minus k plus t of n minus k plus 1, this one. So you can, for example, for 3 times it is like 3 and then minus 3 plus 2 is 2, sorry, yeah, after 3 times it will be like this. After k times the terms is going to be like this. You can use chat gpt to understand this also, or I can explain in person also. And then in step 4, so now we need to understand, to reach t of 1, we have formula for t of n. To reach t of 1, we are trying with one example, like yeah, if n equal to 4, then as per our formula, t of n equal t of n minus 1 plus n, right? So n is 4, so t of 4 equal t of 4 minus 1 plus 3 plus 4. So t of 3 plus 4. Again, if we apply t of n equal t of n minus 1 plus n formula for this one, t of 3, we'll get t of 2 plus 3 plus 4. Again, if we apply t of n equal t of n minus 1 plus n formula for this t of 2, we'll get t of 2 minus 1 plus 2 plus 3. So final answer is like, for t of 4, it's going to be t of 1 plus 2 plus 3 plus 4. So when we start from 4, for example, if n is 4, we need to do 3 times iteration. For example, we applied this t of n equal to t of n minus 1 plus 4 one time here, and second time here for t of 3, and third time we applied for t of 1. From t of 4 to t of 1, t1 is the base case. Hereafter, if we expand, it will become t of 0, which is not needed. So for recurrence, t of 1 is the base timing. So we can say like, for n iterations, the k will be, for n, the iteration will be n minus 1. So k equal to n minus 1. Here we found k equal to n minus 1. Now we are going to apply this k equal to n minus 1 to here. We formed one generalized after k steps, right, in this formula. So here t of n equal to t of n minus, instead of k, we are going to apply n minus 1, as per above rule. So here it's t of n minus 1, t of n minus k plus 1 in that general formula. So after applying this, n minus n is 0, minus into minus equal plus 1. So it will become t of 1. Here n will go and we'll get 2, minus into minus plus 1 plus 1, minus in plus 1 plus 2 plus 3. So likewise the t of 1 plus 2 plus 3 plus n. So here we can find that equation is like sum of natural numbers. So to simplify this one, for example, the sum of natural number formula is n into n plus 1 divided by 2. So here, but we don't have 1. So for this 2 plus 3 plus n, we are saying like n into n plus 1 divided by 2 plus this side it is plus 1. So when it comes to this side, it will be minus 1. So if we apply this into our t of n, our t of n becomes t of 1 plus n into n plus 2 by 2 minus 1. And if we expand n into n square plus n. So one general rule is whenever we have n square, this is the dominant term. So the time complexity will be theta of n square. So we solved this t of n equal to t of n minus 1 plus n using iteration method. The same sum we need to solve using substitution proof method as well. For iteration method, sir has given one more problem. I'll share it in group. Thank you.